Alright, for practice 3, we are going to use a cross-validation data set to determine the accuracy of the regression equations that we found in practice 2. So you will recall that we did an enter method, a forward method, and a backward method. And now we're going to use the equations on our cross-validation set. We're going to calculate the predicted averages using those equations, and then we're going to find the correlation coefficient between the actual batting averages and the predicted batting averages for each of the equations to see which one provides the closest values to our actually measured batting averages in our cross-validation set. So to do this, I think the easiest way for me to do this is to take note that my equations are here. I'm going to go to practice 3, and these are actual batting averages that were measured for a different set of people, and then we've got their baseball stats as well. So I'm going to make a column for my enter predictions, my forward predictions, and my backward predictions. And then I'm going to toggle back to practice 2. My enter regression equation, I can simply copy and paste into this cell. And then all I have to do really is change the cell references. So SO stood for strikeouts. So I now make that a cell reference for this first subject. Home runs was the other variable, so I make a cell reference for that one. I'm going to decrease my variable or my decimal places so I don't have so many. And then I can just calculate the batting averages for everybody, right? Again, based off of each individual's statistics for their strikeouts and their home runs, placed into my equation respectively. Okay. For my forward equation, I basically do the same thing. So I can highlight the equation that I created in practice 2. I can paste it in here, and then now I would be replacing RS with runs scored for my first participant. SO would be for strikeouts, and D is for doubles. Okay, similarly, I will reduce my decimal places, and then I can calculate my batting average for everybody using my forward regression. Lastly, we do the same process for the backward regression. So I'll copy my equation, paste my equation, and then I change my cell references to runs scored, doubles, and strikeouts. You should notice that the forward and backward equations give you the same values because they were using the same coefficients for B. Now what we can do is we need to figure out what the correlation coefficient R is. Okay, so where do I want to put this? I think here's what we're going to do. Paste those back up here, and then R is going to go in this cell. So this will be the correlation coefficient, which we calculate by using the correl function, right? And then we look at a range of data, so we're interested in the actually measured batting averages. And we want to see how closely those compare to each of our models. So we can obtain a correlation coefficient. And then if I want to copy this across, the only thing that I need to do is freeze this cell reference over here so that it's not shifting columns as I go. So I'll put a $sign in front of the column reference or the column letter. The other one should be fine because I want this red box to move over as I calculate the correlation coefficient for the forward and backward regression, so I'll leave that one as is. And then what I can do, I can double click on these to make sure that the appropriate cell ranges were included. And now I have a correlation coefficient for each of my regression equations, comparing the actual batting averages to the predicted batting averages based on the equation that I used. So from here, the question to you guys is to list the correlation coefficients and then to indicate what those mean about the accuracy of the prediction of the regression equations. There is a hint on how to answer this question in the lecture notes, so I would go back and review that if you're not 100% sure. But yeah, we can use cross-validation, basically looking at our correlation coefficients. And you remember that the more closely aligned our actual batting averages are to the predicted averages, the better our model has done at predicting the actual batting averages.